Alright, in section 4.3, we're going to talk about how the derivatives affect the graph. When we find the derivative, by studying the derivative, what information can we get from there that tells us about the original function? Okay? The first thing that we're going to talk about is just a test. It's the increasing and decreasing test. What it says, there's two parts. It says, if f prime of x is greater than 0. Okay, let's think about what this means for a second. F prime of x. F prime, what does that mean? It's a derivative. Okay, what does the derivative mean? The derivative means a slope. Okay, so the slope is greater than 0. The slope is positive. And if you think what having a positive slope is, if we were to draw tangents with all those slopes, they're all pointing upwards. So if you're traveling this way along some graph and they have positive slopes, that means you're going to be increasing along that interval that you have a positive slope. So if we read it one more time, if f prime of x is greater than 0 on the interval, on an interval, then f is increasing. Again, on that interval, whatever the interval is. And then we have a very analogous statement that says if f prime of x is less than 0, so the slopes are negative here. If we were to draw tangents, they're sloping downwards, okay? So you move along the graph, you're always going to be going into the negative direction. You're decreasing. So then f is decreasing. So again, this is a test. This gives us a method to find where our original function is increasing or decreasing. We take the derivative and set it greater than 0 for increasing intervals and solve. And then we take the derivative, which we already did in the first step, set it less than 0 and solve these intervals where they're less than 0. Okay? So let's look at an example. It's find the intervals that where the function is increasing and where it's decreasing. And here's our function. Equals 3, I was giving you the derivative. X cubed minus 3x squared minus 9x plus 4. Okay. So, not prime. There we go. So we want to know where this function is increasing and where the function is decreasing at. So we have a method to find it. It's the increasing-decreasing test. It says take the derivative. So this is just a bunch of power rules. 3x squared minus 6x minus 9. And now if we want the increasing intervals, we're going to take the derivative and set it greater than 0. And if we want the decreasing intervals, we're going to take the derivative and set it less than 0. We solve these two inequalities, and once we do that, we have the intervals of increasing and decreasing. Okay, so let me do some erasing. I want my derivative. I'll write it back up top here. F prime of x is equal to 3x squared minus 6x minus 9. And let's find the increasing intervals first. So that says take our derivative, which is 3x squared minus 6x minus 9, and set it greater than 0. Okay? So, factor of 3, this has a factor of 3, this has a factor of 3, this is 0. So I'm going to divide everything by 3. I get x squared minus 2x minus 3 is greater than 0. Now I'm going to factor this. X minus 3 x plus 2 is greater than 0. Oh, plus 1. Plus 1, not plus 2. Okay, so we could see that x must equal 3 here, and x must equal -1 there. Okay? So if you remember how to solve these type of problems, I'll write it over here. X minus 3 times x plus 1 greater than 0. You gotta put these numbers on a number line. This is solving a polynomial inequality. This is something you would have learned in college algebra or pre-calc. So -1 goes over here, 3 goes over there, and what this does is it splits up the interval into 3 segments. You've got that red interval, you've got the green interval over there, and lastly, you've got this blue interval right there. Okay, so now what we do, we pick test values from each interval. Now, this interval over here, I'm going to just pick the easiest number I can think of. I'm going to pick, so test value -2. So, right there. This interval contains 0, so test value 0. This interval over here, I'm going to pick 4, test value 4. So, all we have to do is check to see, is this inequality over here true or is it false? And we use this test value to determine that. Since we have it in factored form, it's multiplying, and all we care about is if it's positive or negative since it's greater than 0. We could determine if it's positive, is a positive number greater than 0? Yes, it is. So then this interval would work. This would be an increasing interval. But if this outcome turns out to be negative, is a negative number greater than 0? No, then the interval wouldn't work, and it wouldn't be an increasing interval. So that's what we're doing here. So, let's see. You could plug -2 into there. -2 minus 3 times -2 plus 1 greater than 0. Is this true or is this false? Well, here we get -5 times -1 greater than 0. Well, this is a negative number times a negative number. Again, we don't necessarily care that it's going to multiply to a 5 over here. We just care about the sign. A negative times a negative is a positive number. Is a positive number greater than 0? It is. A positive number is greater than 0. So this interval right here worked. Now we do it again. Test value, 0. So if I plug 0 into here, you're just going to get 0 minus 3, 0 plus 1. Is that greater than 0? Well, here, 0 minus 3, that's a negative number. 0 plus 1, that's a positive number, greater than 0. I'm not finding the numbers, the actual numbers here. I'm just thinking in my head, 0 minus 3, well, that's going to be -3. That's a negative number. Again, I don't care about the number. I just care that it's negative. 0 plus 1, well, that's 1. That's positive. I don't care about the number itself. I just care that it's positive. A negative number times a positive number is a negative number. Is a negative number greater than 0? No, it is not. So this interval did not work. And then if we do the test value on our last interval, test value of 4, 4 minus 3 times 4 plus 1, this is 1 times a 5. which is 5. Is 5 greater than 0? 5 is indeed greater than 0. So this interval also worked. So the increasing intervals are the ones that worked. So it's going to be from negative infinity to negative 2 with a bracket, union, and it's going to be from 3. Sorry, I said with a bracket. I meant to say with a parenthesis, not a bracket, with a parenthesis. Union 3 to infinity. Okay, so the reason why we have these, why we're using parentheses, because if I were to plug, oh, I put negative 2 here. I looked at that value. It should be negative 1. Again, I apologize. Looked at the wrong number. There we go. It should have been negative 1 from right here. The reason why we have negative 1 with the parenthesis and 3 with the parentheses here is because if I were to plug negative 1 in here, that's where it would equal 0. Okay, if you recall from the first section, 4.1, when it equals 0, that's where we have minimums and maximums. So when you're at a minimum or maximum, we're not going to say you're increasing or decreasing, because on one side of you, you decreased, on the other side of you, you increased. So that's why we're putting parentheses. If we were to put brackets, that means we're including the minimums and maximums, which we should not do that, okay? So now, if you want to find the decreasing intervals, you pretty much did the work already. Okay, if this was an increasing interval and this was an increasing interval, this one, if we found the test value earlier, it ended up being a negative number. And if you recall, the only difference when doing this with the decreasing intervals is switching that to being less than 0 instead of greater than 0. So this would be less than 0. Is a negative number less than 0? It is. So this interval would have worked for the decreasing intervals. So for the increasing intervals, where it works, that's the increasing intervals. And then usually, more often than not, the ones where it didn't work for the increasing intervals are your decreasing intervals. You do have to be careful with, sometimes they may have a constant interval where everything's constant. So again, you just got to be careful. So this interval would be from negative 1 to 3. And then I would say go ahead in your calculator and plug in the original problem and look at it and look at the intervals of increasing and decreasing and see if they match up with these right here. All right, got another example. F of x equals x over x squared plus 1. Same procedure. Now, I chose a rational function because there's something we got to watch out for when doing this polynomial or rational inequalities. So, first thing, we got to find the derivative. So, f prime of x is equal to derivative of the top, which is just 1, times the bottom, x squared plus 1, minus the derivative of the bottom times the top. So I'll write the top first, and then you just get a 2x here, all divided by x squared plus 1 squared. It's a weird 2. So let's go ahead and simplify this a little bit. And again, there's our original function. We don't need our original function beyond this. We just need it initially so we could find the derivative. So on the denominator, we're going to have an x squared plus 1, all of it being squared. Let's look on the numerator. So we got an x squared plus 1 from right here. And then we get a minus 2x squared, which then if we put together like terms, we get a negative x squared plus 1. But what I'm going to do is I'm going to factor out the negative and make it x squared minus 1 written like this with a negative. So over here we got a negative x squared minus 1. Alright. So, for the increasing intervals, we need to take the derivative and set it greater than 0. For the decreasing intervals, we need to take the derivative and set it less than 0. Okay, that's the procedure. Okay, to solve a rational inequality, let's again just do the increasing intervals. Negative x squared minus 1 divided by x squared plus 1. Quantity squared is greater than 0. To do a rational inequality, it's a lot like doing a polynomial inequality, whereas you need to find where the zeros of the function are. So that's saying, take the equation and set it equal to 0 and solve. Now, since it's a rational function, the only time a rational function can be 0 is if the numerator is 0. So I'm going to take the numerator and set it equal to 0. Well, this negative, I can just divide by negative 1 everywhere, and it'll just cancel. And then this factors into an x minus 1 and an x plus 1 equals 0. So from here, we find x is equal to plus and minus 1. This is where the function is equal to 0. So if you remember in the previous problem, we used those numbers that made the function 0 to put on our number line, and it split our number line up into intervals. Okay? These numbers are also going to split our number line up into intervals. Not only that, with a rational function, when you do this procedure, you have to also find your restrictions, because the restrictions are also going to break up your number line and make more intervals. So to find your restrictions, so let's so we got x is equal to plus or minus 1. We need those. And to find restrictions, try to remember, think about how to find the restrictions. Set the denominator equal to 0 and solve. Yeah, so just to find the restrictions, you just set the denominator equal to 0, solve that equation, and those numbers you're going to include in these numbers to split up your number line. Now, unfortunately, on this example, when we set the denominator to 0, well, I could square root both sides because we've got that squared here. Those will cancel. Square root of 0 is just 0. Yeah, x squared plus 1. You get x is equal to x squared is equal to negative 1. You get x is equal to plus or minus square root negative 1. We can't do that. We're dealing with i's here. So there are no restrictions on this function here. Okay? So just remember the restrictions. This problem doesn't have any. So then the procedure turns out to be exactly the same. You get your numbers that make the function 0. You get your restrictions. You put them all on a number line. So negative 1 somewhere over there, positive 1 somewhere over there. And then again, it breaks up the interval into 3 pieces. And that's just coincidence. It was 3 pieces this time, 3 pieces last time. Just how many numbers we had to break it up to. So now, it's exactly the same procedure. We pick test values. So I'm going to pick a test value over here of negative 2. 0. You always want to pick 0 if you can. It's one of the easiest test values you could use. Test value, pick a 2. Okay, now we just got to plug everything in. And again, we really only care about the sign. Now, more importantly, we only care about the numerator. And I'll tell you why we only care about the numerator. Look at the denominator. Whatever number goes into x right here, you're squaring it. So it's going to be a positive number. You're adding 1 to it. A positive number plus 1 is a positive number. Then, even if this number came out to be negative, which it can't, you're squaring it. So the denominator is always positive. So the numerator could be negative or positive depending on the numbers we have here. So we only care about the numerator. Now we do got this negative sign out here. So let's go ahead and find the increasing intervals. We are going to take the derivative, negative, and I'm only taking the numerator because that's all we have to care about in this instance. That's not true for every problem though. And now just plug in your test values. So let's see, test value of -2. So we got a negative, that's this negative. -2 squared minus 1. Is this greater than 0? Well, let's find out. This right here is a +4. +4 minus 1 is a +3. I've got a negative number times a positive number. Is that greater than 0? Well, that's a negative number is greater than 0. No, that is not true. A negative number is not greater than 0. So this interval did not work. Now let's do the test value of 0. Just plug 0 in here. Now we have that beginning negative, and now we got 0 squared minus 1. Is this greater than 0? Well, we still got this beginning negative, and 0 minus 1 is -1, but that's negative. Is this greater than 0? Negative times a negative is a positive. Is a positive number greater than 0? It is. So this interval worked. So this is going to be an increasing interval. As you see, for a decreasing interval, this one didn't work. We got a negative number here. If we're doing decreasing, flip the sign. So this is going to be a decreasing interval. So you do like them at the same time, essentially. Now, test value of 2. We got the beginning negative. And then 2 squared minus 1, is that greater than 0? If you realize this and this are the same thing, because if you look at this 2 squared, it's going to come out to be a 4, just like this -2 over here came out to be a 4. So we're going to end up with the same result. It's going to be a negative is greater than 0? No. So this one did not work. So now we can see our increasing intervals, or interval, there's only one, is from -1 to 1. And then our decreasing intervals are the ones that didn't work in this case, -infinity to -1, union 1 to infinity. Okay, so now you should take a break and go ahead and try the problem that I have for you in the notes. It's another polynomial problem, so it'd be a lot like the very first one. And then check for the solution on Blackboard.